Hey everybody, hope you're doing okay. This is a video for Wednesday, April the 1st. Happy April Fool's Day. We'll get that out of the way so that you don't think that I'm trying to fool you with anything else in the video. A couple of concepts we've been working on in the worksheets. I want to go over them. I've kind of repeated a few of the concepts from worksheet number 5 and worksheet number 6. Look like some of you kind of struggle with those. So let's focus on how to get these problems done. In today's worksheet, there is a question about two factories and their total cost of producing a certain number of items. And so when you're calculating that, you have to have your fixed costs plus your unit costs. So for example, let me explain what that would be like. Let's say that I'm going to produce, I've got a factory and I'm going to make sticky notes, okay? My fixed costs, if I said I'm going to produce a booklet of sticky notes, and I'm going to go out, I'm going to build a factory. Fixed cost is what it's going to cost me to get started, no matter how many sticky notes I make, okay? So if I have to buy equipment, that's a fixed cost. If I have to buy property, that's a fixed cost. Now, there are other costs that are associated with how many of the items I make. For example, if I'm making sticky notes, I'm going to have to buy paper. How much paper? Well, that depends on how many sticky notes I'm going to make. I have to buy ink or dye. How much? Well, that depends on how many I'm going to make. So we have fixed costs. They don't change. Whether I make one or whether I make a million, my fixed costs are just kind of my costs to get started. And then my unit costs are the costs that are going to go up the more the more units that I make, right? So if I'm paying for paper, if I want to make a whole bunch of sticky notes, then my unit cost for paper, I'm going to buy a whole bunch of units of paper. I'm going to buy a whole bunch of units of ink or dye. So if I don't make very many of my sticky notes, then I'm not going to buy much paper. I'm not going to buy much dye. But I've got a factory sitting there that I had to pay for, whether I was going to make a bunch or little. So let's think about it this way. We have our fixed costs. Plus our unit cost per unit equals our total cost, okay? So the unit cost per unit, that's a multiplication problem, right? Let's say, we're going back to the paper problem. Let's say that to buy a ream of paper costs $5, okay? Well, maybe I just need one ream. So how much money is that going to cost me? Well, 1 times $5 is $5. What if I need 100 reams, though? Well, my unit cost, my per unit cost is still $5. But if I buy 100 of them, my unit cost is 100 times $5, or $500. So that's the way that we're going to calculate total cost. Now, let's look at what that would look like set up as an algebraic expression. Let's say I have a I'm going to call my my fixed cost, I'm going to call it F, plus my unit cost, I'm going to call U, times whatever number that I need of my unit, right? F plus U times N equals T. So F is fixed, U is unit, N is number produced, and T is my total cost. All right? So let's just do this one for fun. let's say that my fixed cost is $10. Okay, my fixed cost is $10. Doesn't matter how many I'm going to make, $10. Okay, my unit cost is, let's say, $2. So now all I need to know is how many I need to produce. So it's $10 plus 2 times whatever number I need to produce. That's going to be my total. So let's say, for example, that I'm producing 10. So I'm going to put 10 for N. Okay, I could produce 10, I could produce a million, but whatever it is, it's going to go in right here. So if I have $10 plus 2 times, let's say 10, $2 times 10 would be $20. So if I had $10 plus 2 times $10 or $20, my total cost would be $30. What if I've got another order and it's 100? I need 100 units of whatever. My fixed cost is still $10. My unit cost is still $2 per unit, okay? And that number is now 100, so $2 times 100 would be 200. So $10 plus $200, my total cost would be $210 if I want to produce 100 of that unit, okay? All right. Another problem we're doing is calculating how much money we need to earn to reach some goal. Okay, this is one of those equal to or greater than problems. If I need to have at least $200, that means I need to have some number that is equal to or greater than. Did you hear that works? In a word problem, the word at least means equal to or greater than. So if I come across a word problem that says I need at least $10, my number is going to look like this: greater than or equal to $10. That means at least $10. So write that down, make a note of it. When you see the words at least, that means greater than or equal to. So in today's particular problem, we've got an individual who has 2 ways of making money. I don't remember exactly what those numbers are, but let's say that method A gets him, let's do easy numbers. Method A is $10. Okay, every time he does it, it's $10. Method B is a amount of money that comes in per hour. Say he's going to get $5 per hour. Okay, so A equals $10, B equals $5. Okay, so let's say that A, whatever it might be, this is his way of making money. Maybe it's raking leaves. Okay, let's say he's going to rake 3 yards. Okay, so 3 times he's going to earn A, and let's say laundry for B, so an hour of working on laundry gets him $5, and let's say that he needs to earn $100. Okay, so plus okay, so we know that he's gonna rake 3 yards, and that's each one is gonna give him $10. He needs at least $100. So we're going to try to figure out how many hours B that he needs of doing laundry to earn this amount of money. Okay, so let's think about this. We're going to solve it from here. We know that that A is $10, so he's already earned 3 times $10 plus our unknown B that he has to find is greater than or equal to $100. Well, 3 times $10 is $30 plus X times B greater than or equal to 100. Don't be fooled by this greater than or equal to sign. Treat it just like an equal sign, and we're trying to solve for X. What is X? The number of hours he has to earn money doing laundry. Okay? All right, so let's go ahead and write in here B is $5. I didn't really write that well up there. So let's go ahead and change this B to $5. And let's solve for x. Okay. First thing I want to do is I want to subtract 30 from both sides. That's going to give me x times $5 is greater than or equal to $70. I've subtracted 30 from both sides. Now to get x by itself, I'm going to divide both sides by 5, right? So x is going to be greater than or equal to, well, how many times does 5 go into 70? That would be 14 times. Okay? In other words, he has to work at least 14 hours of laundry at $5 an hour if he wants to earn $100, at least $100, okay? Notice that when I divided $70 divided by $5, my answer is not in dollars because if I have $70 divided by $5, the dollars actually cross themselves out. That gives me a number, not a dollar sign. It gives me an X, and X is what? The number of hours that he has to work doing laundry, okay? Third problem is a little different. It has to do with graphing a softball throw, okay? So let's think about what this looks like. If we're going to graph, we have the x and the y axis. Now, since the ball is being thrown backward or being thrown forward, not backwards, we're not going to worry about the negative x over here, okay? In other words, life starts where x equals 0. And since the ball is going to land on the ground and it's not going to poke a hole through the ground, we're not going to worry about where y equals 0. In other words, we're only going to deal with one quadrant of our typical XY graph. I know you're used to seeing it, cross, do this, and the y up and down. But a lot of times in real life, when we're graphing something, we don't deal with negatives because negatives aren't going to happen. All right, so here is 0, okay? This is distance. And this is height, okay? So let's say that our person throwing the softball is, and I'm going to count here some measure of feet. Let's go 2, 4, 6, 8, 10, 12, 14, 16, 18. Here's 20, okay? So here's feet going this way. Here's feet going this way, okay? So the person who is throwing the ball is throwing the ball, and the ball is released at the y-axis. Now, let's think about where the arc of the ball, in other words, if the ball was, had smoke coming out of the back of it and kind of left, a trail behind it, where would the ball start if someone's throwing it? Would it start off at the ground? No. Someone who's throwing the ball, they're probably going to release it even above their head, right? They're throwing the ball, they're going to release it above their head. So our arc is not going to start at 0. We're going to start, let's say 6 feet. Let's say somebody is 5 foot tall and they're throwing the ball. The ball is going to be released at about 6 feet off the ground. And let's say that it sails through the air and it's going to land at 50 feet. Okay? Now, we start here. This is our y-intercept. What is y-intercept in this particular instance? Y-intercept is the place at which the ball is released. This is our x-intercept. What is x-intercept? In this case, it's the place where the ball hit the ground. So now we need to trace its trajectory. Now, some people might throw a ball and it's here, and some might throw a ball and go way up here. Well, one further piece of information that we have is that the ball has a maximum height. In its trajectory, the ball has a maximum height. It gets up to a certain point and then it starts to come down. Let's say that maximum height is, let's say the maximum height, we're just going to do this for fun, is 12 feet, okay? Now, where does it hit that maximum height? I don't know, not exactly, but I'm going to guess somewhere in the middle. So somewhere close to the middle of release and land, so somewhere maybe about 25 feet, it's going to reach its apex, okay, the top point of its trajectory. And if that top point is 12 feet, well, that's right there. Now it's a matter of playing connect the dots, right? So if the ball was released here and it landed here, that's what my throw looks like. Okay, so that's how you would graph that problem. All right. Well, here we go. Week 2 is underway of e-learning. No word yet from the governor whether or not we're going to be able to go back to school on May 4th or whether he's going to extend that. I'm praying that May 4th we just walk back into school and act like everything's the same as it always has been. Start off with prayers and pledges and ready to get going and finish the school with a lot of fun. But love and miss you guys, and we'll see you soon.